Hi, I am Dr. TV Haimalakshmi. In this video, I would like to discuss this type of solutions of these problems. That is the differentiation of integral functions. For these problems, for this type of problems, you have to use the fundamental theorem of calculus. Let us see what is the fundamental theorem of calculus. That is differentiation of integral function itself that equal to that function, and it has to substitute the that function that limits, that is d by dx of integral a to g of x, that is the constant, and upper limit is the some function f of t dt. Then it becomes that f of g of x into g dash of x. That upper limit, if the upper limit is the function and lower limit is the constant, then this upper limit function has to be substituted in place of the t, and differentiation of this function. That is the solution of the this type of problems, that is the differentiation of integral functions. This can also be applied if the lower limit is the function and upper limit is the constant. Then you have to put the minus. Then this fundamental theorem of calculus is also there. For then lower limit is a function and upper limit is also a function. In this problem, that lower limit is the 0, that is a constant, some constant, not only for the 0. Here if it is a lower limit is the constant and upper limit is a some function of x. Then how to find out the solution of this problem? That is here, that equal to f, that solution of this differentiation of integral function equal to f of g of x. This g of x has to substitute in place of the t. Here that g of x is the root x. That root x has to be substituted in place of the t. Then it becomes cos of root x, and differentiation of this root x, that is the d by dx of root x, that equal to cos of root x, and root x differentiation that becomes, that is a 1 by 2 root of x, that we get as d by dx of root x. That root x can be written as a x power 1 by 2, and the differentiation of x power n is the n into x power n minus 1. So 1 by 2 into x power 1 by 2 minus 1, 2 into 1 minus 2, that is 1 minus 2 by 2, that is a minus 1 by 2, x 1 by 2 into x power minus 1 by 2, that we can write it as 1 by 2 root of x. So root x differentiation of root x is a 1 by 2 root of x, and this therefore d by dx of integral 0 to root x cos t dt equal to cos of root x 1 by 2 root of x for x greater than 0. If x equal to 0, this will be undefined function, that is the denominator will be 0, so that will be a undefined function. So that f x should not be equal to 0. If x less than 0, that is the negative value. If the negative value under the square root, then that will be a imaginary term, that is not equal to the real value. So this function will be defined for x greater than 0. Let us see the next another function, that is the differentiation of another function, that is d by dx of integral 1 to sin x 3t square dt. Here the g of x is the sin x and the function is the 3t square. Here this sin x has to be substituted in place of the t, that is the 3t square, so that is the 3 sin x whole square, and differentiation of sin x, d by dx of sin x, that is the 3 sin square x, and differentiation of sin x is the cos x, that is the 3 sin square x cos x. Next let us see the another function, that is the d by dx of integral 0 to x square t power minus 2 by 3 dt. Here this upper limit, that is the x square, g of x is the x square, and that function is the t power minus 2 by 3, that x square has to be substituted in place of the t, that is the x square, that is the in place of t, then it becomes x square whole power minus 2 by 3 into differentiation of x square, d by dx of x square whole power minus 2 by 3, and differentiation of x square, that is x power n, n into x power n minus 1, that is a 2 into x power 2 minus 1, that is a 2x. And this x square minus 2 by 3 becomes 2 into minus 2 by 3, that is a minus 4 by 3, and there is another x. So this x power minus 4 by 3 plus, and here there is another x power 1, that is a 1, 3 into 1, that equal to x power minus 4 plus 3 by 3, that equal to x power minus 1 by 3. And so this becomes x power 2 into minus 2 by 3 into x becomes x power minus 1 by 3, and there is a 2. So it will be 2 into x power minus 1 by 3. Then we can write it as 2 by x power 1 by 3. Here this x should not be equal to 0. If it is 0, denominator will be 0, and if it should not be equal to that x should not be less than 0. If it is less than 0, that will be negative value, and then it will be imaginary term, it will not be a real value. So this function will be defined when x greater than 0. Now let us see the another function, another problem, that is the differentiation of the integral of the 0 to root 2 x power 4 plus 3 by square root of 1 minus x square dx. Here root 2 has to be, root t has to be substituted in place of the x. In place of the x, then this root x power 4 becomes, that is the root t whole power 4. That root t minus t power 1 by 2 into 4. That is the, this becomes the t square, root x power 4, that becomes the t square, and x square, that is the root 2 whole square, that is the t. So this differentiation of integral of 0 to root 2 x power 4 plus 3 by square root of 1 minus x square into dx, that is a, this x power 4 becomes the t square, and 3 by square root of 1 minus x square means that is the t, into differentiation of the root 2, that is the 1 by 2 root t. Let us see the another problem, that is d by dt integral 0 to root t x power 4 plus 3 into square root of 1 minus x square dx. Here this root t has to substitute in place of the x. X place lo this root t has to be substituted. That is root t whole power 4 plus 3 into 1 minus root t whole square. This root t whole power 4 becomes the t square, and 3 into square root of 1 minus t. Differentiation of root t is the 1 by 2 root t. We have seen the solutions of these problems, that is the d by dx of integral 0 to root x cos t dt. This root x is substituted in place of the t, then it becomes cos of root x into root x differentiation, that is a 1 by 2 root x. Next, for this function d by dx integral 1 to sin x 3 t square dt. In place of t we have substituted that sin x, then it becomes 3 sin x whole square into d by dx of sin x, that is a cos x. So this is a 3 sin square x cos x. For the function d by dx integral 0 to x square t power minus 2 by 3 dt, that equal to 2 by x power 1 by 3. And the next problem is a d by dt integral 0 to root t x power 4 plus 3 by square root of 1 minus x square dx, that equal to, you have substituted this root t in place of the x, then it becomes the t square plus 3 by square root of 1 minus root 2 whole square, that is the root t, and differentiation of the root t, that is the 1 by 2 root t. And we also solved this problem, that is a differentiation of d by dt of integral 0 to root t x power 4 plus 3 into square root of 1 minus x square dx. Here also that root 2 has to be substituted in place of x. Then it becomes the t square and x square becomes t. So it is the t square plus 3 into square root of 1 minus t into differentiation of this root t, that is a 1 by 2 root t. In my next video, I would like to explain the solutions of this type of problems, that is the lower limit is the constant and upper limit is the function, some function, and lower limit is the function and upper limit is the constant, and both are functions of x, that is both are variables. Thank you for watching.